The last thing that we're going to talk about in this section 20.5 is deprotecting. So if you're in a scenario where you're given the structure of an acetal, like all of these are acetals, and you're given the reagents that are necessary to deprotect that acetal and turn it back into either an aldehyde or a ketone, having to predict the structure of the aldehyde or ketone that you would get can sometimes be kind of tricky. It's not tricky when you're doing it in the lab, because to deprotect in the lab, all you have to do is put some H3O plus in your solution, and then it just does it magically. And it's also not tricky if you're deprotecting in a scenario like this, because you know what you started with, and you know that you're just going to go right back to that same functional group. But in a situation like this, where you don't know what the original carbonyl compound was, it can be kind of tricky to figure out what it was. So what I'm going to do is show you a trick, like a shortcut. There is a mechanism for this, so you could draw the mechanism out. But the mechanism is not beyond your capability, but it's really tedious and kind of a pain in the butt. So instead, I'm going to show you a shortcut. When you're deprotecting on paper, the first thing that you need to do is find and focus on the acetal functional group. The acetal functional group is the oxygen, carbon, oxygen. All of these are going to have OCO, specifically just OCO, not, let me erase that, not OCCO, just one carbon in between the two oxygens, OCO. Let's find the other one, OCO. So you're going to find the acetal group and you're going to focus on it. You're going to ignore everything else. Once you have found the acetal group, you are going to choose one of the oxygen-carbon single bonds. And I promise you, you can choose either one. It's never going to matter which one you choose. You're going to choose one of the oxygen-carbon single bonds. I'm going to choose the oxygen-carbon single bond on the left. You're going to make that, on paper, you're going to make it a double bond. So now it's a carbon-oxygen double bond. You are going to also break off whatever is attached to the oxygen of the carbon-oxygen double bond that you just made. So I've just kind of drawn a line there, break that off. And you're also going to break the other carbon-oxygen bond, the one that you didn't choose. I know this is super overwhelming. So what we've done now is broken this molecule into 3 pieces. And what I'm going to do over here is draw those 3 pieces. And I'm going to attempt to draw them in a shape that resembles, as much as possible, what we did. But notice that I have actually removed the bond that was here and removed the bond that was here. I got rid of those bonds. So we've broken the molecule into 3 parts. So you can see right here, that is our ketone. That is one of the 3 products of this reaction. So that, I'm going to draw it clean. That is the structure of the ketone. The other 2 pieces, OET and ET, those are the 2 alcohols that we used to make the acetal. What we have to do is add H to one and an OH to the other. ETOH and HOET. We're adding an H to one of them and an OH to the other, and we're doing it in a way that we're going to end up with 2 alcohols. I know that's kind of tough, but as you see a couple of them, you're going to get the hang of it. So let's go to the next example. So first thing we did was we found the acetal OCO group. Now I'm going to erase that. What we're going to do is choose either one of the carbon-oxygen single bonds that we had highlighted, and we're going to make it a carbon-oxygen double bond. So I'm going to choose this one right here. We are going to break off whatever is attached to the carbon-oxygen double bond. the oxygen of the carbon-oxygen double bond, and we are going to break the other carbon-oxygen single bond, the one that we didn't choose. We're going to break those bonds. And now let's redraw what we have, and I'm going to draw it in a way that resembles as much as possible the molecule that we had. This time we only have two pieces. This piece right here is the ketone, so that's one of our products. This piece right here is our other product, and to that we are going to add an H and an OH. We're going to add a H and an OH. And those are the two products of this reaction. Let's keep practicing. The next one down here, we already found the acetal group, the OCO. Of those two carbon-oxygen single bonds, we're going to pick one of them to become the carbon-oxygen double bond. We're going to break the one that we didn't choose. And we're also going to break off whatever is attached to the oxygen. And so now let's draw what we made. And I'm going to attempt to draw it, like I said, in a way that kind of resembles that molecule. It looks messy. This is like all one molecule. We don't have three separate pieces here. It's just all one thing. We need to add an H and an OH. And we could clean this up if we wanted. You know that always makes me nervous. I'm always afraid I'm going to lose a carbon when I do that. 1, 2, 3, 4, 5, 6, 7. So that's a 7 carbon chain. 1, 2, 3, 4, 5, 6, 7. We have OHs on the first and the last carbon, and a carbonyl group in the middle. Okay, so we got one more. We have one more that we can practice with. First thing that we need to do is find the OCO, the acetal functional group, and that's what we're going to focus on. We're going to pick either one of those carbon oxygen single bonds, either one we want, and we're going to make it a double bond. So I'm going to choose this one right here. We're going to make that one double bond. The bond that we don't choose, we will break. We will also break whatever is attached to the oxygen that we did choose. And then we're going to redraw with the broken bonds, trying to kind of keep everything in place, because what we really have to be careful with right now is making sure that we don't lose anything, lose any of our carbons. So that looks really weird. Looks bad. We are going to add an H and an OH. Oh, that looks so weird. And then now let's clean it up. Let's make it look nice. CH3OH, I'm more comfortable than writing this line notation for methanol. That just weirds me out. So this one we ended up with two products.